All right, now let's wrap up. Naive Bayes, the probabilities are very close to the exact Bayes. Naive Bayes is a very powerful methodology, and we use all the records in the computations, not just those matching exact predictor profile. Uh, and then the calculations are practical in most circumstances, and it relies on only one assumption here, and that is independence of predictor variables within each class, which naive exact Bayes, you don't have to make that assumption, but on naive Bayes you have to make that assumption. But exact Bayes is not practical, and so it doesn't matter. So you have to use naive Bayes. Um, Independent assumption is typically is the x variables will have some correlation, and therefore it is not strictly speaking justified. But then our especially in predictive analytics scenario, our objective is predictive accuracy rather than assumptions being strictly valid. So often this assumption, even if this assumption is strictly not true, it is all right. The advantages of naive Bayes is that it handles categorical data very well, because there are only some categories for each variable. It works very well with large data set, because you're just counting. The computation is very efficient. It is simple, and there are some shortcomings. That is, it requires a large number of records. If you have a very small data set, and some of the x values individual, not even we are not even talking about predictor profile. We are talking about a particular predictor's value may not be present in the data set. So in order to make sure that all possible values of each x variable is present in the data set, you would require a relatively large set of data. Now, another problem is when the predictors are not categorical, when the x variable is continuous and lots of possible values are there for an x variable, then it is possible that a probability of 0 may come up, because there is no data in the data set for that particular x variable. So when you have that kind of a situation, one possible workaround is you take the continuous variable and bin those continuous variables into bins. Like, for example, you have income. Income goes from anywhere between, say, 50,000 to 250,000, and there are lots of possible values. So you can then bin them into like 50 to 60, 60 to 70, 70 to 80, and so on. Then that reduces the very large number of possibilities, and that's a good workaround for a continuous variable. So when you're looking at naive Bayes, then you should think about binning continuous variables into nominal or ordinal variables. And one more problem is the number of predictor profiles, and this is the reason why exact naive Bayes doesn't work. So, for example, if you have two predictors, right, and each predictor has 10 possible values, then the number of predictor profiles is 1024. And if you have three predictors, each with 10 possible values, then that's the number of predictor profiles possible. And as you keep increasing, you see when the number of if you have 8 number of predictors, each with 10 possible values, so this is what will happen to number of predictor profiles possible. This is the reason why exact Bayes is not practical. It will never work, because you'll end up, usually you'll have predictors in the range of like 50, 60, 100, 200 predictors. And just imagine how many possible predictor profiles there will be, and infinite, nearing infinity, and it becomes impossible for us to implement. Okay. And Naive Bayes is very good with respect to ranking probabilities. So remember, there are two possible ways in which we can apply these methods. One is to find the propensity, the probability, and assign a class to the record. Okay, so that is predicting a classification. Another way is to find the probability and rank order the cases in the order of largest propensity down to the smallest propensity, descending order of probability. That is filtering out the most promising cases, okay, most promising customers, okay, with large probability of success, or most promising case for investigation, which will be in fraud cases. So most probable cases of fraud, you want them at the top. You really don't care in that situation. You really don't care for a particular probability, but you want those cases with highest probability of event to be at the top, and in such cases naive Bayes is really very good.